Okay, this is now the third video on lesson 3.3, and so far we've talked about, on the second video, a lot of strategies that we're going to use. So now we're going to implement these strategies to verify all these identities. Now, on some of these, a lot of the strategies that you're going to see me use aren't necessarily trig. It's just using the fact that it's multiple choice. Now, this one's sort of an exception here. I really don't need to look at the choices to get an idea of what's going on here. We shouldn't. So we should realize there are two identities here that we're looking at. One is you're looking at an odd-even identity. The other is a Pythagorean identity. And so first, let's notice here that negative theta there. And so we know from this odd-even identity that the tangent of negative theta is equal to the negative tangent of theta. Now I'm going to do this. Now notice that this one is squared, so that is definitely going to come along here. So we're going to have 1 plus, and now we'll bring in negative here. So it would be the negative of tangent of theta, and now squared. And notice if I square something that's negative, then that's just going to be positive. So it just give me 1 plus tangent squared theta. And now we should recognize that as an identity there. 1 plus tangent squared theta would be secant squared theta. Now, there again, the idea on verifying an identity is you try to do things to this side. In other words, show your work. How does this side equal this side? Now, let's look at the next one here. And if you say these are actually the choices, okay, so I'll give you a chance just to kind of look at those and figure out which ones are the choices. Now, I was also going to show you some of the strategies that you can use with eliminating a lot of the multiple choice ones. Now, one of those strategies that we mentioned here was to look at the last step to see if the last step makes any sense. So if we just look at the last steps on these, a lot of times that will eliminate half of the possibilities. So notice the first one there, the last step says 1 plus tangent squared equals secant squared. Well, that's certainly true, so that could be a possibility. So this one's okay, so the first one's okay. Now, the next one, though, is totally doesn't make any sense. They've got the secant squared minus 1 equals secant squared. Well, that is totally untrue. So that is definitely not going to be one of the answers. So without even knowing what the question was, I could eliminate that step. Now, C has the same thing that A had, so it would be valid. And now part D, or choice D, you got 1 minus tangent squared is equal to secant squared. Well, that's not true because it should be tangent squared plus 1 is secant squared, or 1 plus tangent squared is secant squared. So that one was false too. And so you see, just by looking at the last step, I've eliminated those two choices. Now, the correct one here, of course, would have been this one. Okay, so A, so notice they've got negative tangent quantity squared would just be tangent squared, and 1 plus tangent squared is secant squared. Okay, main reason I wanted to show you the choices there was to show you how you could look at the last step and basically get a 50-50 shot at getting the problem right just from looking at the last step being incorrect. Okay, now let's look at this next one. Adjust just a little bit. Okay, now on this one, I'm going to sort of start off what I thought would have been a way to do this, but then I'm going to show you a lot of times you sort of have what I call dead ends on this. And my thought on doing this one here would be to change everything to sine and cosine. So in that thought, I would have done this. So notice what I'm doing. I'm trying to take this and make it equal to this. And so I would change everything to sine and cosine. That would give me sine of theta over cosine of theta. And then cotangent is cosine over sine. So cosine of theta plus sine of theta. Okay. And then what I could do there is probably find or multiply this by cosine now. And so if I multiply by cosine, notice this cosine would simplify. And so that would leave me with the sine of theta plus cosine squared theta over sine theta. And then I could actually get a common denominator and add those. But if you look at the choices, none of them have done them that way. And so that's why it's maybe a sort of a good idea here is to try to look at what they're doing and let that sort of guide me on what I should do on how to get the right answer here. Now, there again, we can probably look at the last step and figure out, well, does it make sense or not? And so let's start looking at the last steps here. Okay, so let's look at that, and it might kind of help you here. If you see these, it probably would have been better if they would have done these vertical. Let's see, you got a step here, and then step there, and then finally the last step. Now it's kind of messy here, but that's kind of why you need to look at it a little bit there. Now, the middle steps are going to be the hardest to read. Let me just kind of let you know that part. So first and last steps are really going to be the keys on whether or not or which one is correct. Now, again, let's look at this last step right here. And so let's see if this actually makes sense. So notice they've got it down to 1 over cosine theta sine theta times cosine theta. And so notice, would that be equal to cosecant theta? Well, let's try to make it work. Well, the cosines would cancel out. And so that would just leave you with 1 over sine theta. And 1 over sine theta is cosecant theta. So that makes sense. So that's a possibility. Now, on my next one here, let's look at that. So they're saying that 1 plus tangent theta equals cosecant theta. Well, what they're trying to emulate there is probably a Pythagorean identity, something like that. But 1 plus tangent theta is not cosecant theta. Okay, that would not work. In fact, what they're trying to do is, so you could say tangent squared plus 1 would be secant squared. But that's nowhere near here what we're looking at. And so this last step right there doesn't make any sense whatsoever. Now, let's look at choice C. Now, if you notice, choice C has the same thing as A. So that kind of makes sense. And notice that choice D has the same last step as choice B. They have 1 plus tangent theta equals cosecant theta. Well, 1 plus tangent theta is not going to be cosecant theta. So D there is not a choice either. Okay, so now let's sort of look at the choices that are left here. And so notice the first steps, and that's sort of going to lead us here to a direction to kind of start this on. So notice here that they didn't multiply sort of anything. They left cosine alone. But instead, we've got something inside here and here that's really, really changed. Okay, so I am going to take the approach, I'm still going to change to sine and cosine, because I've noticed within this, all these are sines and cosines. So they went from tangent plus cotangent to a bunch of sines and cosines, and they left the cosine alone. So now, let me change these to sine and cosine, and let's see if you guys can kind of figure out what to do with this. So I'm going to write, so sine theta over cosine theta plus cosine theta over sine theta, and I'm not going to multiply the cosine out because they didn't do it. So somehow they took this, what was left here, and did something with that. Now, the idea there is, well, how can I do something with that? Well, that's two fractions. And so if I combine those two fractions, I would need a common denominator. So that was really the strategy that they used there. They changed stuff to sine and cosine and then used a common denominator to combine two fractions. Now, let's do that and let's see where that leads us. So I've got cosine theta and sine theta in the denominator. So that would give my common denominator cosine theta, sine theta. And so now I went from cosine theta to cosine theta sine theta. So I had to multiply by sine theta. So I need to multiply my numerator by sine theta. So if I multiply the numerator by sine theta, that's going to be sine squared theta. Now, the next one's sort of similar. Now, this one's going from sine theta to cosine theta sine theta. So we'd have to multiply by cosine there. And so cosine times cosine would be cosine squared. And notice that should sort of pop out at us because sine squared plus cosine squared is a Pythagorean identity. And so we should kind of realize, well, hey, that's 1. And now you probably see the right choice, but I'm going to keep on working it anyway just to be sure. And so cosine or sine squared plus cosine squared is 1. So now we're going to get 1 over cosine theta sine theta, and then bring over the cosine theta. And now notice what we can do is we can multiply those cosines there, or cancel those cosines out. And that gives me 1 over sine theta, which is cosecant theta. So if we kind of look at what happens there, let's look at choices A and C that was left. This is what I actually had, or I'd written down. Notice the mistake that they've made. They're saying sine squared times cosine squared is 1. And so we probably could have spotted that mistake if we would have looked very, very closely there. But there again, when you go from the second to the third step, it's going to be very difficult to tell what's going on there. So choice C isn't working out, so it must be choice A. And you can kind of tell if you look at my work compared to what A has there, we've done basically the same thing. So my choice there would be A. Okay, now this one I've sort of left off the choices to see if we can figure out what to do here. Now, notice in this case they've got cosecant of theta plus 1 times cosecant of theta minus 1. Let me write it out here. And so that really doesn't lead me to any kind of identities here. I wouldn't want to change that to 1 over sine because what I have over here is cotangent. So if I had maybe a cosine or a sine on the right side of the identity, then I'd probably want to change things to sine and cosine. So in this case, I really don't see what to do. How about we just multiply them together, okay? And so that might make a little bit of sense because they are conjugates. So I wouldn't have to FOIL them. I would just have to do first and last. So now we could do cosecant theta times cosecant theta. And see, that would give me cosecant squared, which leads me to probably a Pythagorean identity. So that will give me cosecant squared theta. And then 1 times -1 would be -1. And sure enough, that is a Pythagorean identity. Cosecant squared minus 1 would be cotangent squared. And so notice I really didn't need my choices there. Now certainly we could look at the choices and probably eliminate half of them from the last step. And again, the choices could give me an idea about how to sort of get started on it also. Now, here's another one, and this one, probably out of all the ones that I've worked here, bothered me the most. And so a problem that I saw with this is the way I worked it versus the choices weren't anything close. And I actually sent a video to our teacher showing, how the choices were really not the best idea. And I'm going to show you the best idea here real fast. So, and I wouldn't write this down because it is not going to be any of the choices, but we should realize that and say, hey, that is a Pythagorean identity. 1 minus cosine squared would be sine squared. And so that would give me sine squared theta times cosecant squared theta. And let's kind of note that what cosecant squared, or cosecant, is the reciprocal of sine. So I could change that to 1 over sine squared. And then we can note, well, they would just cancel out and just give me 1. So I guess whoever made up the choices thought that that was just too easy to do, and they wanted to waste our time here by doing something silly. So I'm going to reveal the choices now, and you'll see none of the choices were like that. Okay, so let's take the idea here and let's see maybe the last step, if the last step is maybe incorrect with this. So again, I'm looking at just the last step. And so on this one, I get 1 over tangent squared times cosecant would be sine squared over sine squared. Now, as far as I know, I don't really think that's going to work out, but I'm not going to probably mark it out just yet. Now, look at the next one here on our last step. We've got this part here, so somehow this is going to turn into, I'm looking way too far ahead there. All right, let's back up. I'm not really looking at the last step. I'm sorry about that. There's our last step. So they have sine squared theta over sine squared theta equals 1. Well, that makes sense because something over itself would be 1, so I'm not going to rule A out. Okay, next one. They've got cosecant squared theta minus cotangent squared theta equals 1. And so that's actually okay because that is a Pythagorean identity, so that's true. Now, let's look at the next one. Well, the next one was the same as the first one. Sine squared over sine squared certainly would be 1. And then choice D, well, has the same thing as choice B. So really looking at the last step really didn't help me out there a whole lot. So now what I'm going to do is try to figure out what they're doing in the first step. Now I'll actually be able to eliminate a couple of choices from looking at what they're doing on the first step. So let's see if we can kind of sort of make sense out of the first step here. And so that 1 minus cosine squared times secant squared is somehow cotangent squared times cosecant squared. So I really don't see anything that's going that way. Now, let's see. So I'm not going to rule it out, but let's look at the other ones here. So on the next one, we get 1 minus cosine squared cosecant squared equals secant squared minus sine squared times 1 over cosine squared. So it appears that sort of they maybe tried to multiply something out there, but there again, that doesn't really lead me to get to anywhere. Now, the next one, let's see if we can kind of make sense of what's happening here. Would have been a lot better if they'd have wrote all these vertically. All right, so we have 1 minus cosine squared. So notice that is sine squared, so that makes sense. So that's kind of the way that I did that. So sine squared times cosecant squared, but then what was wrong here, notice on the next step is not going to be right. They've got sine squared cosecant squared theta equals 1 over cosine theta times cosecant squared. So what they did is they changed sine squared to 1 over cosine squared, which is incorrect. Sine squared would be 1 over cosecant squared. And so that's not going to work. So C's not working out because they made a mistake there. All right, now I think the last one here is the one that actually works out and sort of makes sense. And so what I'm going to do is I'm going to take the last idea here and work the problem out with it. Now, what they've done there in the first step, and there again, I'm sort of looking at what they're doing in the first step, not to try to figure out the answer, but try to help me get started. So they're distributing here. Cosecant squared times 1 there would be cosecant squared, and then cosecant squared times negative cosine squared would be negative cosine squared, and then cosecant squared. And so that's kind of working out. So that's the approach I'm going to take with this one. All right, so let me write this down and actually start working it now. So I've got an idea of where to start besides the way that I wanted to do it in the beginning anyway. So I guess I really needed those parentheses right there. All right, I just recopied it. And now I'm going to distribute. So that would give me cosecant squared theta minus cosine squared theta cosecant squared theta. Okay, so now let's see if we can sort of figure out an idea of what we can do with this. So what I'm going to actually do here is take this and multiply this out. But to multiply it out, what I'm going to do is I'm going to change cosecant squared to 1 over sine squared. And so you'll see where this is headed, I think, when you actually see this written out. So if we get cosecant squared theta minus cosine squared theta, and there again, I'm going to change this to 1 over sine squared theta. And now if we multiply that out, cosine squared theta times 1 over sine squared theta, well, that would give me cosine squared over sine squared. Now that should ring a bell. So cosine squared over sine squared is cotangent squared. So now this would give me cosecant squared theta minus cotangent squared theta, and that's a Pythagorean identity. And so that would equal 1. And so you notice that's what they've done in choice D down here. Kind of look towards the end. So remember, we were at this point, and so what we did is we wrote that as 1 over sine squared theta. And so that gave me cosine squared over sine squared, which was cotangent squared. So that was choice D there. Okay, so notice you're going to have to use lots of strategies here to do this. You're going to look at multiple choice answers, sort of eliminate especially some that might have errors in them. Look at the first steps and last steps, especially to sort of, the last steps would be sort of to eliminate, and then the first steps would be an idea of, hey, how could I get this started? Okay, let's go to another one now. All right, so we've got, this one is sort of, I think this was the same one. Let me check this. Yeah, that was the same one. I've done it twice there. Okay, let's go to this one now. All right, so there again, let's try to look at the last answers to sort of at least eliminate some of these. I've left off the choices here, so let me label those. Okay, so there again, let's look at the last step. So they have 1 minus, and then parentheses, 1 plus sine theta. So you would have to distribute that negative. So that would be 1 minus sine theta. And so 1 minus 1 would go away. But then notice that will just leave you with negative sine theta. And they just have sine theta. So that's not working out. So that's not going to work. So something has to be valid there. That's screwed up. There we go. And so that's not working out. Now I believe that the next choice, choice B, has basically the same thing. All right, 1 minus, and then parentheses, 1 plus sine theta there. And so that wouldn't work out either, because that would be negative sine theta. So that eliminates that choice. Now, the next one here, they've got 1 minus sine theta. So let's distribute that negative. That will give me 1 minus 1 plus sine theta. And 1 minus 1 would go away. And sure enough, that would just leave me with sine theta. And so notice choices C and D are going to be my valid choices now. I just got to figure out between those two which one to go with. Okay, so let's see if we can sort of spot a strategy as to what's happening. And so look at the steps here. The only difference is this sign in both of them. Okay, let's see if you can kind of tell what's going on with this. So they're switching cosine squared here. Notice that's the only thing that's changing. They're switching cosine squared to 1 minus sine squared. And in this case, they're switching cosine squared to 1 plus sine squared. So in both cases, what they're doing, since that's a squared term, and since you got some ones floating around there, is they're using Pythagorean identities for this. And so we need to spot, well, which one is the true Pythagorean identity? Well, remember this, okay, even though most of the time I'm assuming that you know these, I'm actually going to show you this one out here. So this is our basic Pythagorean identity. Now they're doing the one with cosine. And so cosine squared theta, if I subtracted sine from both sides, would be 1 minus sine squared theta. And so cosine squared is 1 minus sine squared, not 1 plus sine squared. And so that step was invalid. Therefore, we eliminated the first two choices. So this one would have to be C. So notice I really didn't even work anything out on this one. Now, I'm actually going to work this out so you can see what's going to happen with this. Now, this step right here would be very difficult to see. But let's look at this. So I want you to watch me work this out. And there again, even though you may pick the right choice, when you're doing the homework on this, not necessarily when you were doing a test, of course, or a quiz, but when you do the homework, you need to see how to work these out. If you'll start working these out more, then these will get easier and easier and easier. Now, so I'm going to do what they did in their first step there. They changed cosine squared to 1 minus sine squared. So I got 1 minus sine squared theta over 1 plus sine theta. Okay, now their next step was, again, it was very difficult to see. But notice, those are very, very similar. 1 minus sine squared and 1 plus sine. Well, you almost get this canceling vibe going there. Well, we can't cancel because they're adding and subtracting. But notice, and this may jump out at you now, if I say this, 1 minus sine squared is a difference of squares. And so if you see something there, well, you can think, well, that probably means I could factor it. And that's exactly what they're doing. So I'm going to write this as 1 minus, and I'm going to factor 1 minus sine squared there to be 1 minus sine theta times 1 plus sine theta over 1 plus sine theta. And now 1 plus sine theta cancels there. And so that leaves us with 1 minus sine theta. Now I can distribute my negative sign. And so that would be 1 minus 1 plus sine theta. And then 1 minus 1 would go away. And so now that just leaves me with sine theta, which was what I was supposed to get right there. Okay, now on this one, we have to sort of deviate just a little bit from the plan here. And I want to talk to you just a little bit about canceling some things in complex fractions. Usually with complex fractions, we kind of multiply by the reciprocal. Let me show you what I'm talking about. So for instance, if I have 2/3, say, over 1/3. Okay, so we could look at this as being 2/3 times 3 over 1. But notice those 3's would cancel out. Well, I could have actually done that from the beginning. And so if I have a common factor in both denominators, then those denominators can cancel. And so that would just leave me with 2 over 1, which is 2. So same thing is true in the numerators. Let's look at a couple other easy sort of examples so you can get that idea. So I can cancel numerators, I can cancel denominators. So if I have, for instance, let's say 2/5 over, say, 6/10. Well, I can cancel the 2 and the 6 and the 5 and the 10. Now, I couldn't cancel 2 and 10 because one's a numerator, one's a denominator there. But I could do the 2 and the 6 there. I could say 2 goes into 6 3 times, and then I could say 5 goes into 10 2 times. So now that would leave me with 1 over 3 over 2, and then I could actually multiply by the reciprocal there. And so that would just be 2/3. Okay, so you'll see me do sort of a similar thing here on my next problem with this. All right, let's take a look at this one. Now, probably out of all the ones that I've worked, probably besides the one with the easy Pythagorean identity, this was the one that sort of bothered me on how they approach something. Now, I'll show you that when we get to that. Now, let's just look at, and let's see if we can kind of tell by the last step what's going on there. Now, these last steps are kind of hard to see what's happening, but let's look. So remember what I just kind of went over there with you, and I think all the last steps kind of do the same thing. And so on the last step, what's happening here is they're going from this to this by canceling. So notice they can cancel out cosecant theta, and then that leaves them with secant theta plus 1 over secant theta minus 1. Well, that doesn't say that. That says cosecant theta plus 1 over cosecant theta minus 1. So even though they canceled out, for some reason they have secant changing to cosecant. And so that doesn't work, so I can mark that one out. Now, let's look at the next one here. So there again, I could cancel out cosecant thetas, but notice in the numerator here, this should leave me with cosecant theta minus 1, not plus 1. Okay, so that's not working out. So now I've got a 50-50 shot at least. Now let's look what's going to happen on these. I think the last ones here do the same thing. So those cosecants would cancel out. And so we get cosecant theta plus 1 over cosecant theta minus 1. So that sort of looks okay on the last step. And the next problem, let's sort of notice what they do there. So again, the cosecant thetas would cancel out. But notice they go from cosecant theta minus 1 to cosecant theta plus 1. And so that doesn't make any sense there. So really, we actually figured this one out by the last step. I was kind of surprised on that one. But we just look at the last step here to figure out which one was correct. Now, let's look again at this entire process about how I would actually do this problem. Okay? So even though I did find it pretty simple to do this, sure, you can go ahead and answer the question and check it here, but you need to see this worked out for yourself here. Now, to work it out, and there guys, again, you know, if you know what the answer is and you get the answer right, but you still don't see how it's true, then that's when you need to ask for some help. You need to ask me, how are they getting this? Because you really need to understand what's going on with those, not just picking the right answer. Now, here's the idea behind, notice their first step. They're changing their sines to cosecants. And so the idea is, well, why would they choose to do that? Well, look what's on the left side. You have sines on the left side and cosecants on the right. So remember, what I want to do is figure out what can I do to the left side here to make it look like the right side. Well, left side sines, the right sides are cosecant. Well, we should realize then, well, I can write sine as 1 over cosecant. So I'm going to write 1 plus, and then I can write sine as 1 over cosecant. Same thing on the denominator, 1 minus 1 over cosecant. And so you notice on both choices on C and D, and almost really all the choices on the first step, they did that. Now, the hard part is to see how did they get to the next step there. Well, the idea is, well, they were adding or subtracting two values, one of those values being a fraction. Okay, so the idea there is you have to use a common denominator to put those together. And so the common denominator would be cosecant. So what I'm going to do there is have a common denominator. I'm just looking at the top part here of cosecant. And so here I'm going from like a 1 to a cosecant. So I would have to multiply that by cosecant. And then I already have the denominator there. And so I don't have to multiply anything. So I'm just going to bring down that 1. All right, so there's my numerator. Now, denominator, sort of the same thing. I'm going to have to get a common denominator of cosecant. And so I would have to multiply that by cosecant there. And so that would give me cosecant theta. All right, that one's already got the cosecant, so I don't need it. And so I can just bring down my 1. And so now, just like we did on those last steps, those cosecants of theta would cancel out there. Now, that's how I would get that. And there again, you need to realize how all this works. Now, let me show you what I've sort of complained about in the way that they've done that. I'm going to go back to this second step here, and what would have been much better is to recognize it as sort of, well, this is a complex fraction. And recall, we can simplify a complex fraction or a complex rational expression by multiplying everything by the common denominator, which in this case, the common denominator was cosecant. So this would actually have been better. Notice what happens. This was my way of working it. When we multiply everything by cosecant theta. So you remember probably this from algebra here. How to clear a complex fraction is to multiply by the common denominator. So now cosecant times 1 there would just be cosecant. And then these cosecants would cancel out, so that would just leave me with 1. So the same thing happens on the bottom. Cosecant times 1 is cosecant. And then these cosecants cancel out, and that's minus 1. So I get what I'm supposed to, cosecant theta plus 1 over cosecant theta minus 1. That was my idea, yet their idea here was basically going from this step to this step was to find a common denominator. And so they could have just multiplied by the common denominator, and that would have been much easier. Now, let's look at the next one here. All right, so in the next one, let's sort of notice what's happening here. They're going from a secant to a cosine. So my idea on this one was nothing like what they have over there. And I'm going to show you guys my idea first here, just so you can see there was a lot better way. So one way was to change everything to cosines. So I could change the secant theta that's in the numerator here to 1 over cosine theta, and then change the secant squared in the denominator the same way. And then I could multiply, since it's a complex fraction, it's a lot like that last one, we can multiply everything by cosine theta. So that cancels. Those cancel and just leaves me 1 there. And then 1 times cosine there would leave me, or negative 1 times cosine would leave me a negative cosine. Now, what they've done is really absolutely ridiculous. Okay, and so this is where the idea of having these questions as multiple choice is probably the worst possible thing you could do in these problems. Now, let's look and let's see if we can eliminate some of these, again, by the last step. And then we can look at the first step to see, well, what are they doing? Okay, and this one was probably the worst one about figuring out what exactly are they doing. So just hang in here with me now. So on my last step, it looks like all their last steps are the same. And they are. So that's really not going to help me out too much. Now, you may could look at from the second step to the third step to be able to figure out something, but I highly doubt it. So let's just try to figure out what in the world they're doing in the first step. So notice here, I keep dragging that. All right, their first step is they're writing a 1 on the top each time. Well, what they're using here is called a reciprocal strategy. So for instance, let me show you a really simple version of this. So if I have, say, a fraction like 2/3, well, 2/3 could be written as 1 over the reciprocal. So this could be written as 1 over 3/2. Okay, and so that's really what they're doing with this, with their first step. Okay, and so, you know, one thing about it, it would be really, really hard to sort of do that on your own. But once you start to notice this first step where you have all this stuff on the bottom like that, and then a 1 on the top, well, what they're really doing is just that reciprocal idea. Okay, they're using what's called a reciprocal strategy. And I guess the only thing that I could get from that is they're using a reciprocal strategy because secant and cosine are reciprocals. Now, let's actually work this out. And so try to understand what's happening when I do this is I'm going to write 1 over the reciprocal of that. So try to think with me, 1 over the reciprocal of that. So that would be 1 over, and now the reciprocal of secant theta over secant theta minus 1 would be secant theta minus 1 over secant theta. Okay, and so if you'll notice, all the first steps there were the same. So it's going to be trying to figure out what they did in the next step to get to that. And I just kind of realized that all the choices were the same. So I think there was some kind of something that happened there when I copied this over. So sorry about that. We're going to do an additional one just like this one. Now let me finish this one regardless here. Now, the next step here, again, this is going to be something that's not that obvious that you're going to have to pick up on. We can't cancel out those secant thetas. That would be nice, but we should sort of know better. We can't do that because the operation is not multiplication. Now, what I can do here, if I have a single denominator, what I can do instead there is to sort of what we call separate it, or to split it. I call it splitting here. And so what I can do is sort of split that into 2 fractions. And so I can use the same denominator of secant. And so let me show you actually what I'm doing with this now. This would give me secant over secant. And then minus 1 over secant. Okay, so basically you have the same denominator there. It's sort of like unsubtracting the fractions or ungetting a common denominator there. And then notice that we just brought down secant over secant and then minus 1 over secant. Now let me clear that off so it looks a little bit better now. So hopefully you kind of understood what happened there. Now let's simplify from there. Now secant over secant would be 1. And then let's notice, well, that's sort of what we have on our last step here, 1 minus and then 1 over secant of theta would be cosine. Okay, so notice they have 1 here, which was my secant of theta over secant of theta. Now, let's do another one sort of similar to that one since I kind of botched that one up with the answer choices here. Okay, so this is another one. If you'll kind of look at these choices in this column right here. They've got 1 on top, so they've done a reciprocal strategy with this. Now, let's actually eliminate a couple of them from the get-go by the last step. So in my last step there, on this one, they have 1, on the denominator part, they have 1 minus cosine over sine. And so let's see if this makes sense. Well, they're writing that cosine of theta over sine of theta is cotangent of theta. And that's valid. Cosine over sine is cotangent. So A seems to be okay there. Now, let's look at step B. On step B, they have 1 minus sine theta, and then all of a sudden sine theta changes to cotangent theta. So I don't know what kind of magic they're using there, but it ain't right. So that's not working. Now, let's look at the next one. I believe the choice C has the same thing as choice A, and I believe choice D has the same thing there too. Okay, so we only eliminated 1, but at least we got that 1 out of the way. Now, let's use their reciprocal strategy that you're using. I know it's kind of crazy there to do that, but we're going to go with it here. Now, so let's take this, and remember, I want to get to this somehow. Let's take it and write it as 1 over the reciprocal. So that will give me 1 over sine of theta minus cosine of theta over sine theta. Okay, now this is very similar to the last one. Because we have that sine theta down there, it's just that one single term there, we can split that into 2 fractions, and then that'll allow me to do some canceling. So let's sort of notice that all the next steps have pretty much that, except for A. Notice there on choice A, they did the reciprocal wrong. They said 1 over and then sine theta over cosine theta minus sine theta. So that's incorrect there. So I've eliminated that by that first step. Now, choices C and D sort of have the same thing. Now let's use that splitting strategy. So this would be 1 over, and now I'm going to split this so that they both have that common denominator, but then we'll split the numerators up. So they'll give me sine theta over sine theta minus cosine theta over sine theta. And notice it's real similar to the last problem that we just did there. And so that's just going to give me 1. So I have 1 over 1 minus cosine theta over sine theta. And now cosine theta over sine theta. Cosine over sine would be cotangent theta. Okay, so let's see which choice here looks right. I think we could have actually eliminated there again another one because these two were the same on the, they were all the same on that step. So let's look at the third step here. So from here to here, let's notice that they're splitting. So they got the 1 right there from that. I see. They have, this is 1 over, they switched that to cosine for some reason. So I don't know where they got that from, but it's not right. Okay, so finally here I got that was choice D. All right, now let's just look at a couple more here. All right, on this one, notice again here, we're going to secant and cosecant. All right, that's what we're trying to get to. Now, let's maybe eliminate some choices over here. So in this case, now they have 1 over cosine theta minus sine theta equals secant theta minus cosecant theta. Well, that makes a little bit of sense maybe because you have cosine is the reciprocal of secant and sine is the reciprocal of cosecant. Now, they sort of have something similar here, and this actually makes better sense than what's above it, because 1 over sine here, let's look, is not secant, and 1 over cosine is not cosecant. They've sort of got those backwards there, and so that's not working out. All right, let's look at the next choice now. So they've got sort of the same thing, 1 over cosine minus 1 over sine equals secant minus cosecant. Now that makes sense because 1 over cosine is secant and 1 over sine is cosecant. So C sort of looks okay. There again, I wasn't really sure about that one, but I couldn't say that it was wrong. Now, on my last one here, it's kind of hard to tell what's going on here. But let's see if we can sort of make sense of it here. Notice the sines would cancel there, and then these cosines would cancel there, but yet they've got secant minus cosecant, when that would really give you cosine minus sine there. So D is not working. Okay, so now that just leaves me with A and C. Now, let's see if we can get an idea of what exactly are they doing here. And so they're going from here to here. Well, not quite sure what happened there. And same thing here. I really don't see what's going on. So this is, again, where you're going to have to really think about what to do. Now, the key to this is to realizing that the denominator is just one term and the numerator is 2. So I can use that splitting strategy like we did on that last problem. So I can write sine theta, cosine theta as my common denominator there. And now we can separate those numerators. Again, this is called splitting. It's kind of like you undid the common denominator, basically. Okay, instead of writing over a single denominator, you wrote it as over 2 of the same denominators. Now, if you'll notice from there, there's a lot of canceling that you could do there. And so these would cancel, and so that would leave me with 1 over cosine. Right? These would cancel, and that's really the whole point of splitting, is so that you can do canceling. So that's maybe a hint to do the splitting strategy there. If you think, well, you know, it kind of looks like those would cancel out, but we know we can't do that because the operation is not multiplication. But if we split it, then we get the opportunity to do that. And so now we're left with this. Okay, and so now if we go back to our choices, 1 over cosine minus 1 over sine is not the same as 1 over cosine minus sine. And so that eliminates now choice A. And so now we don't have to finish it here. That's the only one that's going to get it right. Now let's see how actually this works. I'm trying to get to secant minus cosecant. Well, 1 over cosine would be secant, and 1 over sine would be cosecant. Okay, last one finally. Now, on this one, again, let's go to our strategies and let's see if we can't figure out, especially eliminating some last choices here, or the choices from the last step. So in this one, they've got cosine of theta times cosine of theta over sine of theta equals cosine cotangent. Now, let's notice what they've done here. If they've switched cosine of theta over sine of theta to cotangent of theta. And that is perfectly okay. Cosine over sine is cotangent. So choice A looks to be okay. Now, let's check choice B. I believe choice B here also, I think we have the same problem as we did last time, where, look at this. Maybe some of those choices. No, they're a little bit different, I'm sorry. All right, so same thing here. On the next one, what they're basically doing is saying cosine over sine is cotangent. Now look at the next one real close. They've got here negative sine times sine over cosine. Now sine over cosine though, check that out. Sine over cosine is not cotangent. So that's not working out there. So that's going to eliminate choice C for me. Now on choice D, kind of the same thing here. They have sine over cosine as being cotangent. And sine over cosine is not cotangent, it would be tangent. So there we go. So on most of these problems, what we can do with that is eliminate the last choice, or eliminate the choices here from the last step. Usually two choices you can eliminate. Now, let's see what we're doing here in this one. So look at the second step and let's see if you guys can kind of tell what's going on with this. So let me just look at the second step. And so they've got cosecant of theta minus sine of theta. And it looks like here they've taken cosecant and written it as 1 over cosine. Because notice they both have minus sine theta behind it. So let's see, is that okay? Is cosecant 1 over cosine? I don't think so. Cosecant is 1 over sine. So hey, the first step eliminated that choice. Now we figured that one out without working it. Now let's actually do this one out by taking what they're doing on the first step, and that's changing cosecant to 1 over sine. So that's that strategy of changing everything to sine and cosine. So let's see how this works out. So we got 1 over sine theta minus sine theta. Okay, now the next step in what they're doing there, if again we're adding or subtracting two things together, one of them is a fraction, the strategy should be to get a common denominator. And so that common denominator would be sine. And so notice from here to here wouldn't require anything to multiply, so the 1 would come down. All right, in this case, I'm going from a 1 to sine, so I would have to multiply by a sine theta here. And so sine theta times sine theta would be sine squared theta. Now, it should be fairly obvious what that is now. 1 minus sine squared is a Pythagorean identity, and so 1 minus sine squared would be cosine squared. So we would get here cosine squared theta over sine theta. Now it's kind of hard to tell what's happening here, so you kind of have to use your imagination a little bit about what's happening. Notice where I am in the process here is I'm right there at that step. Notice what they do here. They break up cosine. So they have cosine squared, so they break it up as cosine theta times cosine theta. Well, why would you want to do that? Well, keep in mind the goal was to get a cotangent. And the way that I can get that cotangent there, if you think about it, is to get right over here a cosine over sine. And so I'm going to break that up. I'm going to break the cosine up. And so I'd have cosine of theta times cosine of theta over sine of theta. And now finally I can say that cosine over sine there would be cotangent. So we get cosine theta, cotangent theta. Now, there again, on all of these, even though a lot of times we're able to pick the correct answer without doing any work, these need to be worked out. And in the case that you can't do that, that's when we need to call on some help there. All right, that was choice B, by the way.